Okay, well, welcome everyone. My name is Daniel Espinas. I am the assistant professor at George Mason University. It's an honor to be here and to present to all of you. I think as Sarah said, I was Lynn's last doctoral student, and so Pam, it's nice to have had you here as one of the first. So the title of the talk is Lynn's Most Recent Innovation in Intervention Science, Improving the Effectiveness and Efficiency of Interventions for Children with Co-occurring Math and Reading Difficulties. So this study was led by Lynn, Doug, Sonia Sturba, Marcia Barnes, Caitlin Craddock, and Carol Hammett. I kind of parachuted in at the end in presenting these results. I know Lynn would want to say special thanks to the many students who participated, their teachers, the Army of Research Assistants who make this possible, and the funding that was provided by the National Institute of Child Health and Human Development. So Paul already kind of set up a lot of this about co-occurring math and reading and learning difficulties, but this is a population of population of children with learning difficulties or disabilities is heterogeneous. And rather than arising from single determinants, math and reading LDs are probabilistically caused by the combined effects of multiple neuropsychological factors. So Paul talked about what some of those are. And math and reading LDs can occur independently. However, often they co-occur, and this is likely due to shared genetic, neural, and cognitive mechanisms. In terms of the functional impact, compared to individuals with LDs isolated to math or reading, those with co-occurring math and reading difficulties experience more pronounced difficulties in reading and math. They exhibit a broader and more pronounced profile of domain general difficulties, such as working memory, processing speed, so Paul talked about this. They achieve less growth in reading and math over time, and they were more likely to maintain their LD status in both domains. So at time one, if you have a co-occurring math and reading difficulty, it's more likely that later on when we check in on you that you're going to maintain that status versus children who have LD in just one domain. And the focus of this work is that they are less responsive to math and reading interventions. And we know that primarily because of the work that Lynn and Doug and others did at Vanderbilt over the years. And we did a review, Lynn and I, last year on the intervention literature in the LD, or comorbid space for RD and MD, and Lynn really owned that space. It was only her studies. She's the only one that had really done work in that area, although many of us, including many people in this room, are interested in this co-occurrence. This grant was premised around this overlap between math and reading, and this question if there's promise in coordinated treatments. And Lynn looked at coordinating many variants of treatments, but in this case was interested in combining reading and math. And reading and math skills draw upon shared cognitive processes, which Paul talked about, particularly at the early grades, learning how to decode and learning calculations. They draw upon a lot of shared processes. A lot of it is learning sound symbol correspondences, forming strong memory traces, and be able to efficiently pull those out of your memory when you need to use them. There's mixed evidence of reciprocal effects of math and reading across development. Depending on the study that you look at, the population, the language, et cetera, sometimes you see that they are predictive of each other. Other times they're not. Sometimes one is predictive of the other. So it's a bit of a mixed bag. A few treatment studies have examined cross-domain transfer between reading and math. These have focused primarily, though, on children without disabilities. And what we're finding from this burgeoning literature is that sometimes you do get improvements in the cross-domain. So if you have a reading intervention, sometimes you do get improvements in math simply from teaching reading. But again, that's with non-disabled populations. Lynn recently found in a study published in 2024 with second grade students, and Doug and Pam were on that study, that children with co-occurring word problem solving difficulties and reading comprehension solving difficulties, that there was cross-domain transfer if you taught toward it. And Marcia talked about specifically teaching to transfer. So that was really promising. And in this study, the question was, can you get cross-domain transfer with calculations and word level reading? And we might be able to do that by developing treatments that target those shared mechanisms to develop more effective and efficient math and reading interventions for children with co-occurring difficulties in those areas. And Lynn really appreciated the need to develop interventions that are effective for this population, but also interventions that are efficient. And I think as many of you who have taught can recognize, there's not much time in the day to provide intervention in one domain, much less interventions in two domains. And I was reflecting the other day that when I was teaching first grade, second grade special education, I had 9 groups I had to meet with each day, and I went through 17 schedules over the course of 1 year. And it was really challenging to find time to provide instruction in both areas. And so I figured, it must be better now, but one of my students recently told me in the math methods course that I teach that they don't provide math intervention in their district, which is going to give me a heart attack. But there is a great need to find efficient ways to provide this type of support. So the study overview, this was focused on first grade students with co-occurring math and read and learning disabilities. And I'm going to go over how that population was identified. And there were 4 conditions. So calculations-only treatment, a word reading-only treatment, and then a coordinated treatment that combined word reading and calculations instruction. And then finally, a business-as-usual control. And the study aims were to test the coordinated treatment short-term effects on students' math and reading outcomes, assess whether improved math skills mediated the coordinated treatment's effects on reading outcomes, and whether those improved reading outcomes mediated the coordinated treatment's effects on math outcomes, which I'll unpack this. And then assess whether improvement in targeted cognitive processes mediated the coordinated treatment's effects on math and reading outcomes in similar ways, and finally to assess whether associated cognitive processes moderated the coordinated treatment's effects on math and reading in similar ways. So the first research question was focused on direct effects, and specifically on superiority of the coordinated treatment over a business-as-usual condition. And so the first question was just that. So does coordinated treatment produce stronger math outcomes than business as usual? And the hypothesis is that it would. And then the research question 1.2a was, does coordinated treatment produce stronger reading outcomes than business as usual? And the hypothesis, again, was that coordinated treatment would outperform business as usual on reading outcomes. There was another set of questions, and this was focused on equivalence. So here the questions were, are math outcomes comparable for coordinated treatment and calculations, and for coordinated treatment and word reading treatment? And the hypotheses were that the coordinated treatment would be comparable to the calculations only and to the word reading only treatments. And to test this, there was a pre-specified tolerable region of plus or minus 0.25 standard deviations. Okay, the second question was focused on indirect or mediator effects. And so question 2.1 was, does reading improvement mediate coordinated treatment's effects on math outcomes? And the hypothesis here was that reading improvement would partially mediate the effects of coordinated treatment on math outcomes. And then research question 2.2 was, does math improvement mediate coordinated treatment's effects on reading outcomes? So here we're looking at cross-domain mediation. And the hypothesis for this was that math improvement would partially mediate the effects of the coordinated treatment on reading outcomes. Lynn was also interested in looking at whether cognitive processes would mediate the coordinated treatment's effects on math and reading outcomes in similar ways. And here she was interested in learning engagement, which included measures of grit and effort and motivation, and then also phonological processing. And behavioral attention was also in learning engagement, and then phonological processing. And here the hypothesis is that improvement in learning engagement and improvement in phonological processing would each partially mediate the effect of the coordinated treatment on the math and reading outcomes. Okay, and then the fourth question was focused on indirect or moderator effects. And here the question was, do pretest cognitive variables moderate effects on the coordinated treatment on math and reading outcomes in parallel ways? And the 3 moderator variables that Lynn was interested in were visuospatial working memory, rapid automatized naming, and paired associate learning. And the hypothesis here was that pretest cognitive variables would moderate the effects of the coordinated treatment on math and reading outcomes in a compensatory manner. So participant screening started off with over 5 years, screening 2,571 children. These were first graders again, in a southeastern district. Stage 1 was establishing that the students had math difficulties with the first grade test of mathematics. The second stage, teachers were able to identify students who had a disability other than the learning disability or insufficient English to participate in the study. And then the final stage was to establish a word reading difficulty using the word identification fluency and average or above average intelligence on the 2 subtests of the Wechsler. And so this yielded 337 students who were randomized to those 4 conditions. So the business as usual, the calculations only treatment, the word reading only condition, or the coordinated treatment. And after attrition, we ended up with 292 students over the 5 years. So participant demographics, again, we had 292 first grade students who were nested in 193 classes in 26 schools. The average age was 6.54 years. It was 57% female, 35% African American, 1% Asian, 58% white, 5% 2 or more, 38% Hispanic, 7.19% received special education services, and there were no significant differences across these and other sociodemographic characteristics between the conditions at pretest. So for measures, there were 4 measures of math. There were 3 that were focused on calculations and 1 focused on word and problem solving. And so arithmetic calculations and fluency, double-digit calculations, and the WJ calculations were the 3 measures of calculations. These were measured at pre and post test and served as outcome measures for that first research question and as mediators for that second set of research questions. They also measured the story problems using a research-developed measure, and that was also measured at pretest and post-test. For reading, there were 4 measures, 3 of word-level reading and 1 of reading comprehension. They used the word identification fluency, the Tower sight word efficiency, and the WJ letter word ID. And so these were measured at pretest and post-test, and then the reading comprehension measure was a researcher-developed measure where students read books and answered questions about them, and this was measured only at post-test. Okay, cognitive processing. For learning engagement, the measures were GRIT, so we used the short GRIT scale, the rating scale of effort and motivation, the SWAN for behavioral attention, and then the C-top lesion and sound matching for phonological processing, the WMTBC, maze memory for visuospatial working memory, the Denkla and Rudel measure for rapid automatized naming, and the WIT task, right? LIT task for paired associate learning. So treatment conditions. So again, there were 3 active treatment conditions in addition to a business as usual control condition. So the first one was the calculations only, or Galaxy Math, and this focused on number knowledge and counting strategies to build calculation accuracy and fluency. The second was the word reading only intervention, and this was Galaxy reading, and this focused on letter sound associations, decoding, sight words, and contextualized reading. And then the coordinated treatment, or Galaxy Star, and this addressed all the objectives in the calculations only and the word reading treatment with the same activities. Consistent across the treatments were dosage, so in all 3 of the active treatment conditions, 45 30-minute lessons were provided to students 1-to-1, and these were delivered 3 times a week for 15 weeks. Tutors received the same training in the conditions. They met weekly with research. These were research tutors, but they met weekly with the project coordinator to receive feedback on the tutoring. And each had 5 to 6 students in 1 to 2 schools. All three of the conditions used explicit instruction or systematic instruction, if that's what you prefer. Scripted lessons, worksheets, posters, flashcards, and if you're familiar with Lynn's work, it's later iterations of some of the previous interventions that she had developed over the years. And activities aimed at building engagement, perseverance, and fluency. And fluency was really a big focus of this, as you'll see. So the coordinated treatment, or Galaxy Math, which I used a version of this when I was a teacher, had 3 segments. So the first was 5 minutes dedicated to an activity called Meet or Beat Your Score. So students went through 2 1-minute rounds with basic facts flashcards. So they would answer as many flashcards as they could within the first minute, and then they'd have a chance to beat their score. And every time they would graph their performance. And that was consistent across all 45 of the lessons. Then the second segment was kind of the instructional segment. And so for Galaxy Math, it included numbers, so lessons 1 through 45, focus on counting from 1 to 9, the number line, reading and writing numbers. It also focused on number sets and families. This started in lesson 4 and went through 36. And so double sets, number combinations, number families, practice cards sent home at the end of each set for students to practice with their families. Students also learned counting strategies for 0 and 1 with pictures and number lines. There were posters, what do I ask? New problems were introduced, so they had 2 minutes to complete problems using that counting strategy that had been taught, and then story problems to introduce a new story problem. Every lesson ended with a bingo activity, so lessons 1 to 3 was focused on handwriting, so writing numbers, and then 4 through 45 focused on basic facts, and these were not the same basic facts that were addressed in Meet or Beat Your Score. And then it concluded with a brief lesson wrap-up, in which behavior-specific praise was provided, and points were added up, and prizes were awarded if students had earned a prize by that point. Galaxy Reading also had 3 segments. So the first was Meet or Beat Your Score, same format, however this was with word flashcards. Then in the lesson it began with letters, so this went from lessons 1 through 45. Students learned sounds of the weeks, and correction procedures. They also learned decoding strategies, so there's a specific procedure that they learned to tap out the sounds, sound it out, say it fast, does it make sense, and correction procedures to apply to those words in a very systematic way. New sight words were introduced in each lesson. There were cloud words that corresponded with the stories that students read in lessons as well. And then 2 segments, one focused on making meaning at the sentence level and then making meaning at the story level. And that followed an echo reading and independent reading. And then the lesson ended with a bingo activity similar to as in Galaxy Math. And a lesson wrap-up with the same behavior-specific praise and points. This is what they look like side by side, so you see that they're meant to parallel each other very closely. And then the coordinated treatment, as I said, addressed all the same content and similar activities. Lessons 1 through 9, 20 minutes were dedicated to math and 10 minutes to reading, and lessons 10 through 45, 10 minutes were dedicated to math and 20 minutes dedicated to reading. This shifted a little bit over the life of the project. Initially, it was going to jump from reading to math each day, and that was a little complicated, I understand, from Katie. So the decision was made to change it in this way. But these were the activities that were addressed, and so they are the same as in the math-only or the reading-only conditions. So the procedures, each year for 5 years, the following cycle was completed. August to September, the students were screened. Then September to October, the research team collected student demographic information and administered pretest. October through February, those 45 lessons were delivered. And March through April, teacher surveys on the treatments were collected, as well as the post-test battery was administered. So the first question is coordinated treatment superior to business as usual for math outcomes? And the hypothesis, again, was that it would outperform business as usual. And it did. So on each of these outcomes, there was evidence of superiority, and we see nice, healthy effect sizes, which was very typical of Lynn, particularly in math. And then the same question was asked for reading. So did the coordinated treatment outperform business as usual on those 4 reading measures? And as typical, the effect sizes are a little smaller for reading, but still, I think they're all significant. And I think what's really promising is that we are seeing effects on comprehension, even though that was really not a big emphasis of the program, but we're seeing some transfer to that, as well as with story problems. That wasn't a big emphasis, but we're seeing an effect size of 0.85 on that, which is really promising. So the second questions were, is coordinated treatment equivalent to calculations-only treatment on math outcomes? And so here we're looking for evidence of efficiency. So we are providing less math instruction, but can we still get similar effects to providing that full 30 minutes, dedicating that full 30 minutes to math? And here we don't find evidence, unfortunately, of equivalence. And to establish equivalence, again, we had that pre-specified tolerable region of 0.25 standard deviations, which is pulled from What Works Clearinghouse. So even though we see some large effects and some significant effects, the confidence interval for those effects fell outside of that tolerable region in each of these cases on math outcomes. That's the case also for reading outcomes. So is the coordinated treatment equivalent to reading on the reading outcomes? And unfortunately, it was not. The confidence intervals, the effect sizes, particularly for word identification fluency and letter word ID, I think are moderate, but the confidence interval falls out of that tolerable region. So we're not considering the 2 conditions equivalent for that reason. Okay. The next question was, does math improvement mediate the coordinated treatment's effects on reading outcomes? And the hypothesis, again, was that improvement in math would partially mediate the effects of the coordinated treatment on the reading outcomes. And there was mixed support for this hypothesis. So improvement in double digits calculation fluency did significantly mediate the effects of coordinated treatment on the Tower sight word reading efficiency. Similarly, the arithmetic combinations fluency significantly mediated the effect of the coordinated treatment on the WJ letter word ID. And finally, improvement on the WJ calculation significantly mediated the effects of the coordinated treatment on the WJ letter word ID. So we're seeing some cross-domain transfer, not on all of the measures and on all the outcomes from the coordinated treatment. And then does reading improvement mediate the coordinated treatment's effects on math outcomes? And the hypothesis here was that improvement in reading would partially mediate the effects of the coordinated treatment's effects on math outcomes. And there was mixed support again for this hypothesis. So the WJ letter word identification did significantly mediate the effect of the coordinated treatment on double digits calculation fluency and WJ calculations. And WIF, or word identification fluency, significantly mediated the effect of the coordinated treatment on the WJ calculations. But we didn't find significant mediation for the other reading measures and on the other math outcomes. Okay, and then the next question was, does improvement in targeted cognitive processes mediate the coordinated treatment's effects on math and reading outcomes in similar way? And here what the hypothesis was that improvement in learning engagement, that was grit, effort, motivation, and behavioral attention, and improvement in phonological processing would partially mediate the effects of coordinated treatment on math and on reading outcomes. And this hypothesis was not supported. And the final question was, do pretest cognitive variables moderate the effect of the coordinated treatment on math and reading outcomes in parallel ways? And here the hypothesis was that pretest cognitive variables, specifically visual spatial working memory, rapid automatized naming, and paired associate learning, would moderate the effects of coordinated treatment on math and reading outcomes in a compensatory manner. And this was generally not supported. However, pretest visuospatial working memory did moderate the effects of coordinated treatment on story problems, which was the math kind of transfer measure. such that the students with the lowest visual spatial working memory at the beginning of the intervention benefited less than students with higher visual spatial working memory. And this is what the plot looks like. So conclusions. So compared to business as usual. Yep. You ready? Okay. So conclusions. So compared to business as usual, coordinated treatment provides an effective approach for improving math and reading performance for children with co-occurring math and reading difficulties, I'd say. However, it's not a more efficient program than reading only or math only at improving math and reading outcomes. Some of the effects of the coordinated treatment on math and reading outcomes are mediated by improvement in reading and math respectively. However, they're not mediated by domain general processes. And effects on coordinated treatment on math story problems, that transfer measure, is moderated by visual spatial working memory, but not by other domain general processes. And that's all. Any questions? If you have any really technical stats questions, Marcia said that she's happy to answer them. But do you have a question, Pam? Okay. All right. Thank you.